Hi, I'm Caroline, and just because a reaction could make 100 grams of product doesn't mean it actually will. Welcome to the world of percentage yield, where theory meets reality. In this video, we'll go through what percentage yield means, why you never quite get 100%, and exactly how to calculate it from experimental data. You'll also feel confident tackling those suggest a reason for a low yield questions that pop up in every exam. If this helped percentage yield finally click, then give this video a thumbs up and subscribe right now. And then watch the reacting maths video because that is often the first step in working out yield. Let's dive in.
So percentage yields, and I hate to break it to you, exist because we don't live in a perfect world. And what they do is in a reacting mass calculation, then we can show how much we should be making if the world was perfect. For example, 50 grams of product. Theoretically, if everything in the process went really, really well, there was no issues, no errors, and we'll talk about some of those later, then this is the amount that we should get. The reality is we often get less. So if we should be making 50 grams, but only 30 grams is made, then we're only getting 60% of what we could have got. And that is what we call the percentage yield. This is how we work it out. So the percentage yield is equal to the actual mass, and that the question gives you. So what we'll say, 20 grams of this was made. You can't necessarily work that out theoretically via a calculation. There needs to be an experimental mass, something that someone has measured for that part of the equation. The theoretical mass, though, you 9 times out of 10 will need to work that out via reacting mass calculation. And if you're thinking, what is one of those? Can't do those either. Head back to one of my previous videos and I will talk you through that step by step. So usually the theoretical mass, for most exam questions, they ask you to work out. Then, because this is a percentage, you then times it by 100. Now, we said the world isn't perfect. Let's get a little bit more specific because they're not expecting in an exam you to say the percentage yield is less than 100% because the world isn't perfect. Actually, there's 3 common reasons why it's less than 100%. These reasons don't change, so they're in the specification and you can just churn them out again and again whenever you are asked. So those are side reactions may occur. So rather than A plus B goes to make the products C and D, then actually maybe B is reacting with D, etc. to make E. So side reactions can occur, not always the one that you are wanting. You might have a reversible reaction or the reaction is incomplete. Or you might get some of the product lost upon separation because usually or most reactions you don't just make one product, you're making a mixture. So there needs to be separation techniques to get a pure product. And whether that's just pouring out of a beaker or whether it's fractional distillation, then you can lose some of that product in whatever method of separation you have chosen to use. The final bit here is if the percentage yield is more than 100%. Now, they don't ask this very often. I've seen it like once in 10 years. But it's possible that they could ask this because it has cropped up. So one reason why it might be more than 100% is because we have contaminants present. So we don't have a pure product. Actually, there is something else in there contaminating it, making the mass look more than it should be. So here's some common mistakes. And the first one is the one that I see the most. So sometimes in a percentage yield question, they ask you to calculate the percentage yield all in one go. And when we work through the worked examples next, I'm going to show you actually in the first example how they can break it down and split it into 2 questions. And in the second example, how they can do it just all in one go. If the question is just calculate the percentage yield when you have 20 grams made of A being made from 50 grams of B, then you need to not just do one mass divided by the other mass because you usually have to work out, remember, that theoretical mass that you could have made. So you will get the actual mass of the product made, and then you'll get the mass of, say, like one of the reactants. So you do the reacting mass calculation to work out the mass of product that you should have got, your theoretical amount. The next one is show your workings, as ever. Whenever there is a calculation question, I'm going to go bang on about this again and again and again. This is not maths, this is chemistry, which means each of your numbers has a specific meaning, and therefore you need to show the examiner that you understand what those numbers mean. So therefore you need to be clearly labeling them and setting your calculation out so we can follow step by step, moles of this, moles of that, etc. And finally, this is another big place where it's very easy to lose marks. Learn how to use your calculator properly. And usually the error is asking your calculator to do too much in one go, where in actual fact you need to use brackets, you need to press equals and break the sum down into different steps so that you don't get a calculator error.
So we're going to use the same method as we use for reacting mass calculation. So if this is new or difficult for you, go back to that video and I will walk you through it step by step. The first step is to work out the tick and question mark. The tick being the substance that we know something about. So we know we have 50 grams of sodium chloride. That is our tick. We're asked to calculate the mass of chlorine. That's our question mark. We're then going to set up our table of mass over Mr. moles. Now we're always going to start with the column that has the tick. So we're told that we have 50.0 grams of the sodium chloride. Now working down the MR, the sodium from the periodic table is 23 and the chlorine is 35.5. Add those together for 58.5. Then to work out the moles, then we do mass divided by MR is equal to moles, and that gives us 0.8547. Now I'm going to keep all of the numbers, or as many of the numbers at this point, because I don't want a rounding error at the end. So no rounding here. Keep as much of the number as you can, and if you can keep the whole number in the calculator, even better. We're now going to switch columns over to the column that is the question mark. To do that, we're going to look at the reacting ratio. So we have a big 2 in front of the sodium chloride and no number in front of the chlorine, which means it's a 1. So we have a 2-to-1 ratio. So in order to swap columns 2-to-1, I'm going to divide by 2. And that therefore gives us, again, not rounding, 0.42735. Now I'm going to take this number of moles and work up the column. So the MR of the chlorine, 35.5 times 2 is 71. In order to work out the mass, then we times the 2 together in order to get 30.3 grams, not forgetting units, as that's the answer to this part of the question. 30.3 grams. So we've now done the hard bit. So we have calculated the theoretical mass, and that is going to go on the bottom of this equation. So we should have made 30.3 grams, but we didn't. It tells us, the question tells us that 25.0 grams only were made. Let's times that by 100 in order to turn it into a percentage, and that gives us 82.4%. If you are an A-level student, then you need to think about significant figures. At GCSE, less so, but the question might still ask for some sig figs. So this answer here is to 3 significant figures. 82.4%. Let's look at a question where they haven't broken it down step by step. They have put both bits into one question. So last time we worked out the theoretical mass and then separately we worked out the percentage yield. Here, the question is just giving it as all in one go. This is the first mistake that you do not make. You do not do the mass of chromium divided by the mass of chromium oxide. You never do that. You always have to do, in this style of question, a reacting mass calculation to work out the theoretical mass of chromium you could have made. So let's start there. We're going to start with the tick and the question mark. Now it says chromium is a useful metal, so that we're looking at the percentage yield of chromium. That's what the question is asking us about. Calculate the percentage yield of chromium. That is therefore our question mark. We are told that we have 1.25 kilograms of chromium oxide. That is therefore our tick. It's our substance that we know something about. Let's set up our table. So mass over Mr. Moles. Can't spell moles today. There we go. And let's work down the column with the tick first of all. Now, here's the next little thing that we're not going to get caught out by. So we are given the mass of chromium oxide in kilograms. We need to convert that into grams by timesing by 1,000. So we actually have 1,250 grams of chromium oxide. You always have to convert into grams first. Now let's work out the MR of the chromium oxide. So use your periodic table to look these up. The chromium relative atomic number, is 52. That we times by 2 because it's Cr2 plus 16 times 3. So that is 152. 52 times 2 plus 16 times 3. In order to work out the moles, then we do mass divided by MR is equal to moles. And that gets us to 8.22368. At this stage, again, I'm not going to round. In fact, I'm going to keep the whole number in my calculator if I can, in order to avoid a rounding error at the end. To switch column, we now look at the reacting ratio. So we have a 1:2 ratio here. So we're going to take that 8.22, etc., and times it by 2. That gives us 16.447. Now it's time to work up. So the AR of the chromium is 52, again off the periodic table. And to work out the mass, we do those two times each other in order to give the answer of 855 grams. That is the theoretical maximum mass of chromium that we could have made. Now we work out the percentage yield. So we're told that we actually made 756 grams. We should have made 855 grams. Times that by 100 to turn it into a percentage, and our overall answer is therefore 88.4%, and that is the 3 significant figures.
Thanks for watching, and if this was helpful, don't forget to hit like and subscribe now for more new GCSE and chemistry videos every single week, and check out the playlist for the rest of the chemistry calculations. Let's boss chemistry together.